Diffusion. Diffusion is the movement of particles from a region of higher concentration to a region of lower concentration down the concentration gradient. Diffusion is the evidence of kinetic molecular theory, which states that matter is made of tiny particles which are in constant motion. We can take example of diffusion from our daily life, like fragrance of perfume spreads around, small dust particles or smoke diffuses into air to cause air pollution, or when we open a bottle of soft drink, carbon dioxide gas moves out and it diffuses into the air. Breathing also involves diffusion of gases. Oxygen goes in and diffuses in our body, while carbon dioxide gas diffuses out. This exchange of gases that takes place in our lungs is all because of diffusion. You can also check out in the laboratory by performing simple experiments, like you can put a few drops of potassium permanganate in a beaker of water. First, the crystal ruptures and then the purple color of the crystal spreads through the water as the particles of crystal mix among water molecules. In the second experiment, you can put a gas jar containing air. It is placed upside down on another jar containing bromine gas, which is a reddish brown gas. Now bromine vapors spread out and mix among the air particles, and in both the gas jars you can see bromine or air particles completely mixed up after some time. Now this rate of diffusion depends on two factors. The first one is molecular mass or density of particles, and the second one is temperature. So for molecular mass or density of particles, we can say that particles with lower molecular mass or density diffuse faster, they move faster. So this can be proved by performing the experiment in which a long glass tube is taken. Cotton wool soaked in ammonia solution is kept on one side and it gives off ammonia gas. On the other side, cotton wool soaked in hydrochloric acid is kept and it gives off HCl gas. Now you can see that when the vapors will travel in opposite directions and they will react together, you can see the reaction. The equation is given. Ammonia when it reacts with HCl, it forms ammonium chloride. And the place where ammonium chloride will be formed, it can be seen, it forms a very dense white cloud or white smoke forms over there. So that shows the formation of ammonium chloride, and you can see that this ring or smoke is formed closer to HCl as compared to ammonia solution. So this shows that the ammonia particles have traveled a longer distance than HCl gas. The reason is that HCl is a heavier gas with a relative molecular mass of 36.5, whereas ammonia is lighter as compared to HCl with the molecular mass of 17. So that's the reason that ammonia vapors travel more distance as compared to HCl. So lower the mass of the particles, faster the gas will diffuse. The next factor is temperature. So higher the temperature, greater will be the rate of diffusion due to the faster motion of the particles. As the temperature goes up, as the temperature increases, the kinetic energy of the molecules also increases, and when the kinetic energy increases, the molecular motion increases. As a result of that, diffusion also increases. Now here is another experiment performed for diffusion. In the first diagram, you can see the apparatus, which consists of a porous pot. Gas particles can easily diffuse through its walls, and this porous pot is connected to a U-shaped glass tube containing colored water, which acts like a manometer. Manometer is a device which is used for comparing the pressure in the pot with the atmospheric pressure on the other side of the tube. Over here there is atmospheric pressure. We can label the pressure over here as X and the level in this limb as Y. As you can see over here, the level of X and Y is same because right now the air pressure or the atmospheric pressure on both the sides is the same. Now in the diagram 2, a beaker containing hydrogen gas is inverted over porous pot. Now what will happen, that hydrogen gas is lighter than air, so hydrogen diffuses in the porous pot faster than air diffuses out. As a result, what will happen, that the pressure in the porous pot will become greater than the atmospheric pressure. So what will happen, that the level of X will move down and the level of Y will rise. But this change will be only for some time. After some time, the level of X and Y will come back to their original position. In the third diagram, you can see that the beaker now contains carbon dioxide gas. Carbon dioxide gas is heavier than air. So carbon dioxide gas diffuses in the porous pot slowly, then air diffuses out. Now what will happen, that in this case the pressure in the porous pot becomes less than the atmospheric pressure. As a result, what will happen, the level of Y will go down and the level of Y will rise for some time, but after some time both X and Y will come back to their original positions. I hope you have understood the topic. So thank you for watching. Please subscribe, like and share.